Alright, we're going to see if our intuition from our previous two videos holds about how to multiply complex numbers. So it looked like something to do with the scales, simply scaled, to do with the size of them, which comes from the modulus. And it looked like the arguments seem to rotate together, so sum in some way. So I've got two complex numbers z and w here and here in Cartesian form, which we're going to multiply to get wz. And again, we'll do that in Cartesian, so I've got half a chance of plotting it. So 3, 4 plus fraction 3 root 3 on 4 I, close bracket, open bracket, fraction negative 5 root 2 on 2, no, on 8, plus 5 root 2 fraction plus fraction 5 root 2 I on 8, close bracket, multiplies out to be this horrible surd, which is roughly negative 1.811, take 0.485I. So that value is over here somewhere, negative 1.75, 1.8 is over there. Take 0.485 is going to be, that's why these are 0.5s, aren't they? So 0.5 is there, 0.45 is there, so it's in between these two. So it's somewhere here, it looks like it might be. WZ. So, let's have a think about angles and arguments and moduli. So, let's get our original radii. Here is Z. That there is the argument of Z. And then this here is the argument of W. And then this over here takes us to WZ. This whole thing all the way around is the argument of WZ. So what we would like to see is that this argument here plus this argument here add up. So if I put that there, is this angle here the same size as this angle? This one and this one. If they are, that means that we've simply added the arguments together. Now we can check that because we can work out the arguments here. This has an argument of pi on 3 radians. This has an argument of 3/4 of pi radians. This has an argument of 13/12 pi. Well, let's just see. So we'll take the pi as a factor. Is a third plus 3/4 13/12? Well, that is going to be 4 plus 9 twelfths and twelfths. It is. So this angle, all the way from here, all the way around there, is the same as this angle and this angle added together. So it looks like multiplication has this rotation effect. Now in terms of the size of these things, this has a radius or a modulus of 3/2, and this has a size of 5/4. Alright? So, what is the size of this? Well, if we've got this right, this should be 15/8, because that is 3/2 times 5/4. And if we do check the modulus of this, which should be there, I wonder if I can get that out of this come out, so shift absolute ans, there we get 15/8. So the absolute size of that is 15/8. You can do Pythagoras on that to double check. Obviously I've given you some rounded things there, so there'll be significant error, significant figure issues. But that should be enough to give you an intuition that multiplication with complex numbers has a rotational part and a stretching, a scaling part. And they seem to combine in fairly simple ways. The modulus of things just multiply together, and the angles of things just add together. So we'll bring that up into algebra next time, and then maybe I'll even show you an algebraic proof. Enjoy.